In this, we are going to learn how to find the Laplace transform of a function using the definition. So what we're trying to do is, so we're going to do find the Laplace transform L f t, where ft equal, let's say we have 4t minus 3. So let's look at this function. So let's use the definition to find the Laplace transform. So what's the definition of the Laplace transform? So it is defined as an improper integral. So it is L f t is, this is the definition, it is 0 to infinity. It's an improper integral. So we have the function 4t minus 3 times e to the minus st. So that's a transform part, e to the minus st. So you multiply the function by e to the minus st and integrate from 0 to infinity, and that's what we call the definition of the Laplace transform. So now the goal is to evaluate this one, and you can see that once you look at this function, what comes to your mind is the integration by parts. So we can use the integration by parts to do that. So we know, according to theory, when you have a function like that, we normally pick this one as the u function and this one as the dv part, because we normally pick u so that once you take the derivative, it is simpler than the original one. So that's exactly the right choice. So now what we do, let's use the integration by parts formula to do it. So that means we need 4 ingredients for that. So let's look at them. So what they are, so we know that u equal 40 minus 3, and then dv equal e to the minus st dt. So we have those two, and then what you do normally, we take the derivative here. So it is du equal 4 dt, and then we take the integral. So for the integral we can use the formula. What the formula says, here is considered as a parameter, or in other words a constant. So that means we're going to divide by that. So that means it is e to the minus st divided by the constant. In this case it is minus s. So we have all 4 ingredients here. So now we're going to use the formula of the integration by parts. So this is integration by parts. So let's use the formula now. What the formula says? Formula says it is uv minus v du. So we can recall that here. So if we have v du, so it's u dv equal uv minus v du. So that's the integration by parts formula. So we can use that now. So once you use it, what's going to happen? So you can see uv. So uv means the product. So we're going to multiply the two. So that means you're going to get 40 minus 3 times e to the minus st divided by minus s. Now we can take the limit. What are the limit? Infinity and 0. Those are the two limits. And then we have a minus, but you can see that v has a minus sign. Because of that minus sign, this is going to be plus. And also you can see that once you take the derivative du is a constant, so we can take the constant also out. So we can write this one as 4 out, and s also parameter, you can write it outside, and then only thing left is 0 to infinity e to the minus st dt. That's what you get. So this is simply coming from the integration by parts formula. Now what? Now you can see that the second integral you can evaluate. That's very easy. It's the same thing as we did before. But what about the first one? First one, you can see that it is at 0, everything is fine, because once you plug in t equals 0, because we try to find the two limits now. Once you plug in t equals 0, everything simplifies. But what happened at infinity? At infinity, you can see that when t goes to infinity, e to the minus st goes to 0, because it's an exponential function with the negative power. Because we assume that s is positive. That's assumption. We assume that s is positive. So S is positive, so let's write it here. S is positive. So one goes to infinity, one goes to 0, so we don't know. That's an what we call indeterminate situation. So since this indeterminate, what we can do, we can use the Lopitas rule for that. So let's use the Lopitas rule and see how it simplifies. So what you want to know is, we want to see what will happen to the t times e to the minus st when t goes to infinity. So let's do that. So I'm going to do that here. So what we need to do is limit t goes to infinity, t times e to the minus st. So you can see that um, the first function goes to infinity, the second function goes to 0, so we don't know what's going to happen. So in that case, what we normally do is we can use the Lopitas rule. So to use the Lopitas rule, we have to write that in the right form. That means we have to write them in the infinity or infinity form. So let's do that. So once you write them in the infinity or infinity form, or 0 form, it doesn't matter. What we try to do is we try to bring it to the easy one so that we can take the derivatives easily. So what I'm going to do is I'm going to leave t here and I'm going to bring the exponential term down. So that's like normally what we do. We like to write with positive index. Everything looks good. Now you can see when t goes to infinity, this goes to infinity, that also goes to infinity. It's an infinity over infinity situation. That's a Lopitas rule situation. So we can do that. We can take the derivative of the top and bottom. So if you take the derivative of the top, what do you get? It is simply 1. If you take the derivative of the bottom, and you can see that s act as a constant. So because of that, this is going to be s times e to the st. Now what's going to happen? We know that we assume that s is positive. So when t goes to infinity, this term simply goes to infinity. So it is 1 over infinity. That means it simply gives you 0. So that means this limit is 0. Now we can use that in the formula. So let's go back now. So that means when you plug in the top limit, what will happen? The expression going to be simply 0. So this is 0. And then minus, but you can see that there's a minus sign also here. So because of that minus sign, this can be plus. So and you can see that there's one more minus. How many minus sign we have now? So we can see that there's a minus sign when you plug in 0, you get a minus sign because that's the bottom one. And also there are two other minus signs. There's a minus sign here. So there are two minus and there are three minus signs. So since there are three minus sign, at the end you simply end up getting a minus sign. So it's a minus, and you can see that when you plug in t equals 0, what's going to happen? E to the minus st become e to the 0, which is 1, and then you end up with negative 3 over s. So this part simply give you 3 over s. Okay, now what about the second integral? In the second integral, we have 4 over s already, and when you evaluate the integral, we have a constant, act as a constant, is a parameter. So you can see you can simply write e to the minus st over minus s. So it's very clear. You just divide by the constant and then infinity over 0. Same argument. When t goes to infinity, it is an exponential decay function. So that means it's going to go to 0. So if you look at the graph, so what's going to happen in this situation is, so the graph looks like this. It's going to go like that. So that's what happened to the e to the minus st function, because we assume that s is positive. So that's what happened when t goes to infinity. It's going to go to 0. Perfect. So that means when you plug in infinity, it is 0. But when you plug in s, when you plug in t equals 0, the top goes to 0. So that means when you plug in, when you plug in t equals 0, this is e to the 0, it is 1. So that means it's a minus situation because it's the second one, is the bottom one. So that means you're going to get a plus there. So that means you're going to get, so if you write them, so we have negative 3 here, 3 OS plus 4 OS. So you're going to get 0 from the first one. then plus 1 of s, why plus? Because the minus sign, this minus sign, make it plus. Okay, now we're gonna simplify them. So that means you're gonna simply get, we write the actually it's 8, so this is s. So we're gonna multiply the two, so you're gonna get 4 over s squared minus 3 over s, and we assume that s is positive. So that is the Laplace transform of the function 4d minus 3.